Hey everyone. So hopefully you had a good spring break. Hopefully you guys got some rest. I definitely did. Did a little bit of grading though, so I was still doing some schoolwork. I watched Tiger King, which was interesting. I'm actually only 2 episodes in, but so far it's pretty weird. So I'm definitely intrigued. I'm gonna keep watching it. I don't know if I'd recommend it though. If you have like absolutely nothing to do, maybe I'd recommend it. Otherwise, it's just absolute craziness. But yeah, that's a little bit about what I did. So hopefully you guys had a good spring break, a good break from everything. So we're going to get back into things now, and we're going to continue where we last left off. So we are looking at section 8.4, which is adding, subtracting, and multiplying radical expressions. Alright, so we're going to jump right into it. Just a little bit of a reminder, like radicals, are radicals that have the same index and the same radicand. So remember that the index is this little number on the outside, and when we don't see a number, it's 2, so it's a square root. And then the radicand is what's inside or underneath the radical. Alright, so we're going to go ahead and basically simplify this. This is asking us to subtract and then add. So what we need to do is make sure that we have like radicals. Well, in this case we have the same index, but we definitely don't have the same radicand. So we can't just stop here and say that it's not possible. What we need to do is we need to simplify each of these radicals and then find out if we can actually combine them or not. Alright, so what I'm going to do is I'm going to rewrite cube root of 54 as the cube root of 27 times the cube root of 2. And the reason that I want to do that is because 27 times 2 equals 54. And remember that there is the product rule that says that we can separate factors of a radical. Hopefully you guys can hear that there's a very loud motorcycle outside. Alright, so next I'm going to just keep simplifying this. So I know the cube root of 27 is 3, because 3 times 3 times 3 is 27. So this whole radical simplifies to 3, and then there's no cube root of 2, so I'm going to keep it as cube root of 2. So what I just did is I simplified cube root of 54 into 3 times the cube root of 2. And I'm going to do the same with the next one. Alright, so I know that 16 is 1 times 16, 2 times 8, 4 times 4, but I'm going to choose 2 times 8 because I know that 8 has a cube root. So the first thing is I'm going to bring down that minus 5 because I don't want to forget it. Alright, and now I'm going to rewrite cube root of 16 as the cube root of 8 times the cube root of 2. Again, because 8 times 2 equals 16. Alright, but what I want to do is I want to break down the cube root of 8. So I'm just going to bring down this first part that we had. I'm going to bring down that minus 5. So the cube root of 8 is 2. So these two are multiplying, so I'm going to do times 2. There's no cube root of 2, so I'm just going to bring that down. Alright, so far what I have is 3 times the cube root of 2. I can simplify this by doing negative 5 times 2, and that's negative 10. And then I can bring down the cube root of 2. So far things are looking good because I still obviously have the same index, but now my radicands are starting to match. And then the last one, there's nothing to do. We can't do the cube root of 2, so I'm just going to bring it down plus cube root of 2. Now that everything obviously still has the same index, but now also has the same radicand, what I can do is I can combine these. Alright, now they are considered like terms. And so what I'm going to do is I'm going to add just the coefficients. Alright, and I want to show you that this is basically the same idea as if we had something like 3x minus 10x plus, and the coefficient here is technically a 1, 1x, right? If I replaced all these cube root of 2's with x's, these are obviously not the same, but the idea of how to add and subtract them is we just take the coefficients and add or subtract those. So that's what we're going to do with our radicals. So 3 minus 10 is negative 7, and negative 7 plus 1 is negative 6. So we have negative 6 as our coefficient, and then cube root of 2 stays the same, and that is our final answer. Alright, so the next example that we're going to do alright, we have the cube root of 98 plus the square root of 98. Alright, so you can see right away that the indexes do not match, right? This is a cube root and this is a square root. The radicands do match. And so although we already know that these are not going to be like terms, we can't walk away from this problem without even simplifying it. So what we're going to do that is we're going to start breaking down each of these. Alright, so let me just take a look at my notes. We could try to break down 98. I'm going to grab my calculator. Alright, so we have 98. Let's start with 2. 2 and 49. Alright, so 2 is prime, and 49 is 77. That's prime. And so remember that because the index is 3, we're looking for groups of 3. So there's obviously no group of 3 here, so what that means is that the cube root of 98 actually cannot be simplified. So we're going to keep it, the cube root of 98. But this work was actually pretty helpful because now when I go to simplify the square root of 98, this index is 2, and so I know that I need a pair. I need 2 of the same thing, and I can already see the breakdown of 98, and I know that there are pairs of 7s because this is just 2 times 49, and the square root of 49 is 7. So I could just break it down, right? I didn't actually need to do all this work again. But when I break it down, I end up getting one group of 7s, so I have a 7 on the outside. Remember, this is a square root, and then 2 goes inside. Alright, and now this is my final answer because I can't break it down any further. Alright, and then let's try another example that's similar to this. Alright, so we're going to try radical 27x, so now we have some variables, minus 2 times radical 9x, or square root 9x, plus square root of 72x. Alright, so again, we can see that the indexes are the same, they're all square roots, but the radicands are definitely not the same. Alright, so we're going to have to break these down. Well, I can rewrite 27 as the square root of 9 times the square root of 3x, and it's really your choice where you put that x, but I'm going to put it with the 3 because if I put it with the 9, I wouldn't be able to find the perfect square root of 9x. If it was 9x squared, then I could. So I'm going to choose to leave the x with the 3 because I know that's not going to break down any further. Square root of 9 is 3, and then times radical 3x gives me this. Right, I just combine those two. Next I'm going to bring down this piece right here, so the square root of 9, I technically could do this. I'm going to bring down the minus 2, and I could split this up into square root of 9 times square root of x. I could have also done that up here, actually. And the reason that's helpful is because I can take the square root of 9. The square root of 9 is 3. So negative 2 times 3 is negative 6. And then I have my square root of x. Right, and then 72, well, I know that 72 is 36 times 2, so I'm going to go ahead and rewrite that. I'll do it right here, plus 72 is the square root of 36 times 2, and I could separate that x again. I could have just put it with the 2. But the reason I'm doing that, let me just bring everything down, is now I can do the square root of 36, which is 6, and these don't break down any further, so if I multiply these, I get radical 2x. So you can see that these are not like radicals because none of the radicands are the same. So this is as far as we can go. And that is our final answer.